Okay, so it says what angle is included between JK and MJ? It's going to be angle J, exactly right. So where those two sides meet, you see they meet at angle J. Our next one up, I'm going to erase my picture so I can draw the next one. We have KM and we have ML. Where do they meet? At angle M. And we're going to do the same thing for the next group. So we have CD and we have BC. Where do they meet? C. Our last ones here, I guess not last ones, we have a couple. We have AB or BA and AD. Where do they meet? A. And then we have our last one officially on this type. Exactly right. It's going to be angle B. So BD and BC, and you guys see that they meet at B. So if you look at this, there is kind of like a little shortcut. Do you guys notice the trend happening here?
Yeah.
Okay, what's the trend? Okay, both of you did a nice job with that. You see the same letter occurs more than once. So in this one, J occurs more than once, twice. So J is the answer we picked. Here, M occurred twice. It's going to be here. Here, C occurred twice. Here, A occurred twice. Here, B occurred twice. So everyone you're seeing more than once is going to be where those sides meet. Yes, ma'am.
Wouldn't we have to name M like KML or something?
Yeah, we should have. I apologize. So M really should have been named KML. I agree.
Yeah, for sure.
So angle KML because there's more than one angle occurring there. So we'd name it KML. Okay, so here it says, what additional congruence would you need to show to perform these indicated congruence statements? So here it tells you, it wants you to use side, angle, side. Right here. Right, when we look up here, we see we have a side. We have an angle. We need to prove the other side. So you want to make sure that angle is the included angle because it's side, angle, side. So which sides do we have to show are congruent?
B.
B what?
B.
You're close.
B.
BC is congruent to EF. So we want to show these two are congruent to create the fact that you have side, angle, side. So remember when we have side, angle, side, that angle is wedged between the two sides. So where the sides meet, that's the angle we're talking about. So for side, angle, side, it has to be that one. So here we need to show CD or CB and FE. Let me create that F to be full. Okay. Our next one up, we see we have JL congruent to KM. What other piece of knowledge do we know that's not shown? Say it again. KL. So what she's saying is that KL is in both triangles. We see that it's shared. So we know that KL is congruent to KL. So KL is congruent to LK or KL. And we know that by what property? Reflexive. So if we wanted to prove this by side, 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 that you see here, side, 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 we see right now we have two sides. We have to prove the other side if we were going to prove it that way. So which side would we have to prove? Or which sides? JK is congruent to LM. And then our last one of this group for right now, we want to show this one by side, angle, side. They tell us that those two, SP is congruent to SR. We know something else. What else do we know? It's the same as the last one. What else do we know? Reflexive property. SQ is congruent to QS by that reflexive property. Right here. So 9 times out of 10 when you're doing these problems, if it has a shared side, you're going to have to use the reflexive property. You can put it in there. You can see that it's going to happen. So now we want to use side, angle, side. You have two sides. Remember when we do side, angle, side, the angle has to be the included angle. So the one where the two sides meet. Which angle is the one where the two sides meet? So it's S, but since there's more than one angle occurring there, we're going to label it with all of them. So we have angle RSQ. Remember the vertex goes in the middle, so since we're talking about S, S goes in the middle. It's congruent to angle PSQ. So is there enough information? So for us to do this, we're going to list out the congruence that we know. So if I started with KL is congruent to, and this one you see all of them have the same number of tick marks. But comparing it to the same triangle wouldn't make very much sense, right? So if I said that KL being congruent to JK, that wouldn't get me anywhere. It tells me that's an isosceles triangle, but I don't know anything about the relationship with the other one. So we want to make where we're making a comparison with both triangles. So we can say that KL is congruent to JM because they're both triangles now. And then that leaves my other two. So KL, JM. So my other two would be KJ is congruent to LM. And now we've dealt with all of the things shown directly. So we want to know if we have enough information to show side, side, side and explain. So do we have enough information? Not officially yet, but we know one more piece of information that we didn't write yet. What do we know? You're close. JL is congruent to LJ. So we're back to that reflexive property. So again, if it's in both of the triangles, we can say that it's congruent to itself. And now we have one set of congruent sides, two sets of congruent sides, three sets of congruent sides. So yes, we can prove this by side, side, side. So tomorrow on your test, when you get this question, I'd want you to list out what you know is congruent and then tell me how. Okay, our next one up, you're going to decide if there's enough information to say if this is side, angle, side, and explain your reasoning. So we're going to do the same thing here. We're going to list what we know. So PQ is congruent to.
Hold on, what did you say?
Yeah, PQ is congruent to, and she told us RQ. Okay, we know an angle PQS is congruent to angle. You're close. So remember vertex in the middle. RQS, yep. So RQS, and then our last thing that we know. SQ is congruent to QS. And how did you know that? Reflexive prop. Okay, now when you look at this, do we have enough information to show that it's side, angle, side? We have a side, we have another side, and we have the angle where the two sides touch. So that's the included angle. So side, angle, side. So yes, we do. Yes. Try that to make that actually look like yes. Side, angle, side. So now we're going to do the one next to it. Once again, we're going to list what we know. So let's start over here. We have JN is congruent to. Yep, MN. One tick mark for each of those. We move our way to the two tick marks. So KN is congruent to and L. And then we have one more piece that we know that is not directly shown. So, can you say it again? So we don't know anything officially about JK. Taylor, do you have an idea?
Angle J and K is congruent to angle L and N.
Okay, so you said J and K. Sorry, I missed the end part there. So what she's saying here is J and K. Let's try that again, Jenkins. Angle J and K is congruent to angle M and L. And what did you say? How do we know that? Yep, vertical angles. So if we draw those in here, do we have enough information to show side, angle, side?
No. Yes.
Yes. So we have two congruent sides. And where the two congruent sides meet is at a common angle between them. So that's there's a shared angle. So we see yes, that works. Yes.
Is this back and forth, right?
Yes, it is.
How much?
Okay, so this one says decide if there's enough information to show that the triangles are congruent. If so, tell which congruent postulate you're going to be using. So I'm going to list those out with you guys. Which ones did we learn? So we learned side, side, side. We learned side, angle, side. We learned angle, side, angle. And we learned angle, angle, side. So all of those, except for the last one, has to deal with the included side or angle. And remember, this one's the non-included side. So we're going to look at these pictures and we're going to see what we have and if we have enough to tell you which one. So here we have two sides and an angle. Which one of these deals with two sides and an angle? So we see side, angle, side would do that. So we want to know if the angle is included between the two sides. We see that it is. So it had to be side, angle, side. So SAS. What do you guys think about this next one? There's something that...
Side.
Yep, it's going to be side, side, side. And we know this because of the reflexive property. RQ is congruent to QR because of that property.
We gotta roll with it.
Nope, I'm okay. It's just writing side, side, side. But I want to make sure you see it. This one, we have information that it is parallel lines. So you know you're going to have to go over here and use some of these parallel line information. But we know one thing about the side in between. So what do we know about KH? Yep, it's going to be congruent to HK. Nice job. KH, congruent to HK. And we know that because of that reflexive property. But now we want to talk about something else to be able to prove it. We don't know anything about this side here. There's no information given. But we might be able to find stuff out about the angles. So when you guys see that they are going to be parallel lines, you know that you're going to have to use same side interior, same side exterior. Same side interior, alternate exterior, alternate interior, or corresponding. Well, right here you have parallel lines. Everything's happening between those parallel lines. So you know it's going to have to be an interior. So now you have to decide, is it going to be same side interior or alternate interior? Well, same side interior is supplementary. So supplementary means 180, so we don't want to use that. But alternate interior is about congruence, and that's the whole idea there. So we're going to want to use alternate interiors. I'm going to draw the two that would be alternate interior angles, two sets. So our first set of alternate interior angles will be here and here. So you see your parallel lines cut by a transversal. They're both inside the lines, interior, opposite sides of the transversal. But we also have another set happening over here. I'm going to do it in purple. Now you have to decide which one allows us to do it. So Taylor told us it's going to be side, angle, side. So if you look at it, your options were to use the purple one. So you'd have side, side, angle. And I told this to my last class. If you read those together, right? Side, side, angle. If you read it in the other direction, that's a bad word in here. We don't use that. So you know it's not going to work. So we know it can't be side, side, angle. But we have the other option of side, angle, side, where the two sides meet at that red one. So that one we also saw by alternate interior. So with that, we knew it had to be side, angle, side. Our last one here with D. Not last one. I was being optimistic. So what do we think this one's going to be? Side, side, side. And we know that because of the reflexive property. You're going to get a little tired of it, I know. But we're going to hit it hard here today. Our next one. Side, angle, side. And how'd you know that? Because you looked at it. So we have another property that tells us that. What's that property? Reflexive. Reflexive. Okay. Now we're on to F. We know one thing that's not shown in that picture. What do we know? Yep, DB is congruent to BD. How did we know this? Reflexive. Okay, so now we know two sides in both triangles. So we have side, side, side. We have to show that these two sides are congruent. Can we do that? Do we know anything about them? No. So then we have to look to see if we can prove anything about angles. Do we know anything about any of these angles? No. So with this one, the answer is no. We don't have enough information, so no. Okay, after that, we're going to go on to this one down here. You have a congruent side, a congruent angle, and a congruent side. Which one is this going to have to be? You're close. Yep, side, angle, side. So we have two sides and an angle, so it's going to have to be side, angle, side, because that angle split right between those two sides. And then here we have A. So be careful. What do you see here? You have two A's in there, but we only need one A, right? So one congruent angle, two congruent sides. But if you spelled that out, bad word in here. We can't use that. So we know this is going to be no.
What did you say?
So if you spelled that one out based on what we have, that would form a bad word, right?
What's a bad word?
It's not a thing. Okay, so on this one, we want to use the diagram to complete the congruent statement. So this goes back to 5.1. Remember we did 5.1, we had the positioning tells you which angles are congruent. So angle A is congruent to angle Q based on the fact that they are both in the first position. We also have that angle B is congruent to angle P. They're both in the second position. And then the third position is going to be the last two. We're going to have that C is congruent to R.
This is a given, like we're just.
So you can base this off the congruent statement like we did in 5.1. So based on that statement, we're able to see this. QP, because they're the first two letters. And then we're going to move on to the last two letters. So here our last two letters are BC and PR. So they're going to have to be congruent. So BC and PR. And then the third one you can see are going to be congruent based on the fact that it's the only ones left. But if not, you also know that it comes from the last letter and the first letter. So CA is going to be congruent to RQ. So I will make a comment about that in 1 second. Give me 1 second about that.
Girl, it's not.
So
All you doing is
we're
lying.
going to look here and we're going to see what angle R is congruent to. So what is angle R congruent to? Angle C. And we know that AB is congruent to? So QP. And then we have triangle BAC. So we can look at that BAC. So we know B is congruent to P. We know A is congruent to Q. And we know that C is congruent to R. I forgot my little triangle symbol, so let me add that in. Or we could rewrite this same statement as RPQ is congruent to. So C, what'd you say? CBA. Okay. So Raj asked, did we have to write all of this out? There's nothing wrong with drawing it all out. I'm all about that. But if you remember from 5.1, we talked about congruent statements. We can see that based on these letters. So if we wanted to know what angle is congruent to angle R, you see what position R is in. It's in the third position. So it has to be congruent to the one in the third position here, angle C. Same thing here. Angle BAB, first, or angle side AB, first two letters, has to be congruent to the first letters over here, QP. So did you really have to draw this out? No. But if you feel like you might get confused, it's a nice way of doing it. And then for these, you could just match up the letters. B was in the second position, P is in the second position, A is in the first position, Q is in the first position, C is in the third position, R is in the third position. And we can find those based on just that little congruent statement. So tomorrow's quiz, I will not give you this chart, but for time's sake, I wanted to make sure we had something today so you guys could kind of see the way they are set up. So tomorrow you'll make the chart and you're going to complete this. So when you look at it, you remember statements and reasons and a T-chart, and then after that, you always list the givens. So without doing anything else, we can list our givens. PQ is congruent to RS, and we knew that QR is congruent to SP. How did we know those? Because they're given. So tomorrow, if you drew the chart and you did these like 4 parts, so the given part and the statements, you would have 5 points. Yes, ma'am. So when you write it, you just want to make sure you write it just like this. So whatever's here, that's all you have to do. So we just take it directly from here, and you just write it here. Yep. So each time, just copy directly over here. And your last statement, so if you know nothing else, your last statement is always your proof statement. So whatever's here goes in that part. So we can now just jump there and say that triangle PQR is congruent to triangle RSP. Now we just have to find out the middle part. So we know that the triangles are going to be congruent. We have 2 congruent sides. So if we're going to prove this, what else can we show? It tells you the reason, but you don't have to use that. So you have two sides, so we can either look for another side or another angle. Do we know anything about any of the angles? So we know nothing about the angles, so we're going to do what Raj says. We want to do PR.
Why you gotta do PR?
You could do RP. PR is congruent to RP, and how did we know that? That reflexive property again. So we see that with that reflexive property there, we have created a side, side, side. So our reasoning here would be SSS. Let's go on to our next one. Once again, you have two givens, so let's list those out. You write just like it is over the other part, and your reasoning is always given. So AC is congruent to DC, and BC is congruent to EC. And how do we know both of those? Yep, they're given. So with looking at this, you have the two givens. Since we know how many steps, you know this one's going to have to be that the two triangles are congruent. You can write your proof statement there.
Well, you said you're not gonna give us what tomorrow?
I'm not going to give you the numbers. It's just going to be a question like this, and you're going to create all of this.
So we gotta even write given.
Mm-hmm. And those are points for all of them.
I'm not writing none of that.
Okay, that might be hard for you. So ABC is congruent to triangle DFEF. So we want to prove it here. It tells you by side, angle, side. None of the pictures have any of the symbols on it, so let's add those symbols. AC is congruent to DC, and BC is congruent to EC. We want to do side, angle, side. What do we know? We know vertical angles. When you have that bow tie, those kissy fish meeting, two lines intersecting, the angles opposite of each other have to be congruent because they're vertical angles. So we can write that out as angle ACB is congruent to angle DCE. And it's because of that vertical angles. Now we have enough information to say side, angle, side, because that's the included angle. And we can move on. So this is all going to be about that 5.1 where we listed out everything that's corresponding angles and corresponding sides. So we have core angles. And we have core sides. So remember core angles, we're going to go through and we're going to do one arc. And we're going to compare it to the one that has one arc. So over here we have one arc, which is angle V, which is congruent to angle one arc C. So two arcs, we have angle W, which is congruent to angle D. And then we have angle X, which is congruent to angle E. Thanks, Yusef. Okay, so we see those based on the congruent marks with those little arcs. So the next part is going about congruent sides. So normally when we do this, we try to start with the one tick mark. When we start with one tick mark, we start with the side that has one arc. So we have VW. So we want to make sure that we're at least being systematic. So just for the sake of just trying to be that, we usually try to start with the one tick mark and the less side, and then it builds from there. So it doesn't necessarily matter which one you start on as long as you stay consistent with how you build it, and that the sides that are also corresponding to it, you write the same way. But this helps me be consistent. So we have VW. On this one, we have CD, yep. And then remember, the next line always picks up with the letter from the one before. So since this one ended in a W, this one begins in a W. So what goes with the W in this one? WX, nice job. And this one has to pick up with D what? DE, nice job. And then the last one picks up with that X. X what? V, which is congruent to E. Nice job, guys. EC. So to write that congruent statement, when we do this, we read down the lines. So we have triangle VWX is congruent to triangle CDE because we read directly down that line. So here we have two congruent sides. What else do we know? It's going to be side, side, side based on the fact that this is congruent to itself. GI is congruent to IG.
On the test, we got to write all that GI.
If it's just telling you to name it, no. But I'm just saying it so you know if you're going back to study. So over here, which one's this going to be? Side angle side. And once again, we know that reflexive property is occurring here. XZ is congruent to ZX. I'm just going to write reflex. Okay, over in this one, number 11. Which one's this one going to be? So this one's going to be side angle side. And how did you guys know that? Vertical angles. So again, those kissy fish, two lines intersecting, the angles directly across from each other, are going to be congruent because they're vertical angles. On number 12, which one's this? You're really close. Remember, we have two angles in this one. So it's going to be, say it one more time. Angle, side, angle. Yep. So since we have two angles, you just flipped your letters. So angle, side, angle, ASA. Remember that we have to make sure that those are in between it. We see that the side's directly between those two angles. So that works really well. On number 13, we know one other piece of information. What do we know? SU is congruent to US by that reflex. So be careful here. We have two angles and we have a side. The first one we've seen like this today. Is that side between the two angles? No, it's not. So which one of these allows it to not be between the two angles? Just be careful. You want to make sure you're using two A's and one S. So when you guys look at this, make sure you're using two A's and one S. So two A's and one S leave you here. Angle, angle, side. So remember, angle, angle, side is the one AAS where that side is not between the two angles. So it's the only one where it's not directly between it. So AAS. So I think this one's a little tricky just to make sure you know what you're identifying. And then the last one here. We have a congruent angle. We have a congruent side. Do we know anything else? Nope. So this answer is no. Or none, I think is what the actual directions tell you to say. So the first statement, what did you guys put for your first part? GH. Yep. And how did you know that? Given. Nice job. Okay, our next one up, we'd have that FG is congruent to HE. How did you know that? Given. So tomorrow, if you made this chart and you list this out, you have 5 points, right? That's a lot of points in this problem. This problem's only 9 points total. So you have 5 points right here. So now it's getting the other spots. So you see that you have two congruent sides. When we look at those, we notice that these two are also congruent because that's not shown in our diagram. We want to prove that these two triangles are congruent. So we can either try to prove angles or you could try to prove that remaining side. Which one are you guys going to do?
Angle.
We're going to try to do the remaining side because we know nothing about the angles. You had this on your paper. I saw you have it. So it's going to be that remaining side. So how do we prove that this side is congruent? GE is congruent to EG by what? Reflexive prop. And then last but not least, you state what you set out to prove. Right here we have EFG is congruent to GHE. And what did you use? Side, 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 angle, side, angle, side, angle, 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 side. SSS. Nice job. So guys, when you look at this, if you see that they have a shared side, go to the reflexive property. If you see it's two intersecting lines, go to the vertical angles. If you see it's parallel lines, remember you're going to have to probably use alternate interior or corresponding. Okay. And then let's go to our next one, 2. So for number 2, we know that angle D is congruent to angle G. How did you know that? Given. The next one tells you it's given, so we're just going to list our other given. DF is congruent to GF. Our third one tells us that we know, let me draw those in. Angle D is congruent to angle G. DF is congruent to GF. It tells us that we know EFD is congruent to angle GFH. How did we know that? Vertical angles, two lines intersect, the angles across from each other are those vertical angles. And then last but not least, now that we know that, we can say our two triangles are congruent. DEF is congruent to triangle GHF. And how did we know that? You're close. What do we have? We have two angles. So we have angle, side angle. So you just flipped your letters. So ASA. So this one tells you that PQ is congruent to RQ. I'm going to draw that in. PQ is congruent to RQ. And how did we know that?
This is given.
Yep. Okay, our second part here is that M is the midpoint of PR. And we know that because it's given. What does it mean to be the midpoint? It's halfway through. It's congruent into two congruent parts. So we can say that PM is congruent to MR because a midpoint creates two congruent segments. So that allows me to draw this in here. And our next step tells you already that it's going to be QM is congruent to MQ. How did we know that? Reflexive. Nice job. And then after that one, we now know our whole thing. So triangle PQM is congruent to triangle RQM. How did we know that? Yep, SSS, side, side, side. We have enough minutes to finish number 4. Let's try to do that really quick. That way you have one less thing to do for homework. Okay, so number 4. Let me scroll up a little bit, I guess. So we have SZ is perpendicular to RT. So our first blank is going to be SZ is perpendicular to RT. When things are perpendicular, we know that they create what? A right angle. Our next one says that angle RSZ is congruent to angle TSZ. And yep, it's given. And then the next one, now that we know we have perpendicular lines and we have an angle that's going to be congruent, it tells us our reasoning is that perpendicular lines form right angles. So we want to state which ones were the right angles. So angle, so you guys are close, you have to put one more letter with it. So SZR or RZS and angle TZS are going to be right angles. So since they're perpendicular, we have to state that we know they formed right angles. So it might seem a little redundant, but we have to say it. Now that we know that they're right angles, what do we know about right angles? They're congruent. All right angles are congruent. So for your reasoning here, you just write all right angles are congruent. So now that we know that these are congruent, we have one more step to show before we're done. What else do we know in this picture? Reflexive property. So SZ is congruent to ZS. And then we have our last one stating what we know. So triangle RSZ is congruent to triangle TSZ. And how did we know that? You're close. You keep flipping the same letters. So you have two A's. So ASA. We only have, well, okay. Okay, so here it says, what congruence do you need to show by this postulate? Well, this one tells you they want you to show it by side, side, side. We have two sides, so to prove by side, 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 we have to show the other side. So we'd have to show that BC is congruent to AD. Nice job. Our next one says it's side, angle, side. Well, you have two sides. We'd have to show an angle. Well, since it's side, angle, side, it means it's the angle included between those two sides. So where the two sides meet would be E and T. So we'd have to show that angle E is congruent to angle T. And then our last one over here, you look at it and it only looks like you showed one angle. But we know something about this part right here. What do we know about these two angles? They're congruent by the fact that they're vertical angles. So we know that by vert. Okay, so if we want it to be angle, side, angle. No, we don't want it to be angle, side, angle. We want it to be angle, angle, side. It has to be one of the sides that's not directly between the two angles. So we can't use this side and this side, but you can pick the other ones. So we could show that FG is congruent to KJ. Or, you don't have to write this, but if you would have written it, it would have been fine. GH is congruent to HK.